Hello. In this video, I'll provide an overview of what rational numbers are, as well as determine if a decimal repeats or terminates. So, what are rational numbers? A rational number is any number that can be expressed as a fraction of two integers a and b. A can be any integer you like, while b can be any integer except for 0. The reason being is you cannot divide any number by 0. On this slide, I will give some examples of rational numbers. This first example is 1 over 3. Both the numerator and the denominator are integers, and the denominator is not 0, so 1 over 3 is in fact a rational number. This next example is negative 7 over 2. Like integers, rational numbers can also be negative. This third example we see is 4 over 1, which simplifies to 4. One important property of integers is that they are also rational numbers. And this last example is 0 over 5, which simplifies to 0. I said in the previous slide that you can make the numerator anything you'd like, so we can make the numerator 0 if we want. It just simplifies to 0, because 0 divided by anything is in fact 0. Well, except for 0, of course. While rational numbers are defined as fractions, we can convert any fraction to a decimal simply by dividing the numerator by the denominator. This can create two types of decimals, the first one being a terminating decimal, and the second one being a repeating decimal. If you would like to know the nitty-gritty details of converting a fraction to a decimal, check out the Converting Fractions to Decimals video. One type of decimal we can get is what's called a terminating decimal. Terminating decimals are decimals that have an ending point. So when we divide 5 by 8, we get 0.625 as our answer. One thing to notice is that there is no other digit after the thousandth place. This means that this decimal terminates, or has an ending point. Another example of a terminating decimal is 1/2, which simplifies to 0.5 as a decimal. Notice that there is no other digit after the 10th place, so that means that 0.5 is a terminating decimal. And then another example of a terminating decimal is 1 over 5, which simplifies to 0.2. Like 0.5, there is no other digit after the 10th place. Another type of decimal you can get is what's called a repeating decimal. Repeating decimals have an endless repeating pattern. 1 over 3 equals 0.3 repeated. In math, we normally put a bar above the digits that repeat in the decimal. So instead of putting 0.3 and then having it go forever, you put a bar above the digits that repeat in the decimal. Another example is 2 over 11, which equals 0.18 repeated. This is to show that it's not only one digit that can repeat, but multiple digits in the decimal can repeat forever. So instead of writing out 0.181818 forever, you put 0.18 repeated to signify that the 18 is a repeating pattern and goes on forever. Now let's determine if some of these decimals repeat or terminate. This first example is 2.15. Since there is a bar above the 1 and the 5, this is a repeating decimal. This next example is 0.61874. Since there is not a bar above any of the digits, this decimal terminates. And this last example is negative 1.89713. Since there is a bar above the 1 and the 3, this is a repeating decimal.